have already discussed little L2, the space of square summable sequences. So, I have a sequence x sub I which satisfies I is equal to 1 to n mod xi squared is finite. So, this is a square summable sequence and becomes relevant in the context of quantum mechanics. In fact, we have been looking only at L2 most of the time without saying so, because when I expand a state psi in terms of a basis set phi n, this n is not to be confused with that n. With coefficient Cp, and given that this is an orthonormal basis and that psi is normalized to 1, it implies that summation over p mod Cp squared is 1 and therefore certainly less than infinity. So, the probability amplitudes Cp when expanded in this manner happen to satisfy the requirements of a square summable sequence, and therefore little L2 becomes very important in the context of understanding the framework of quantum mechanics. I also mentioned another space which was the space of square integrable functions defined in the region AB. These would be functions of a real variable x and if they are square integrable functions psi of x, they would satisfy psi star of x, psi of x dx is finite, and a and b could well be minus infinity and infinity respectively. So, this is a kind of direct extrapolation of a square summable sequence. These are square integrable functions of x. So, today I will talk about certain aspects of square integrable functions of x. In other words, we will be discussing the space capital L2 of a comma b. So, square integrable functions. The linear vector space is L2 of a comma b. So, this is what we will talk about today. L2 of a comma b is an example of a separable Hilbert space. So, that means that the space L2 of a comma b has a denumerable infinity or a countable infinity of basis states, and this could be an orthonormal basis. You can always make it an orthonormal basis. Since it is the space of functions, clearly the basis states are functions of x, and any state, any arbitrary state in this linear vector space can be expanded in terms of these basis functions. So, since a and b can take various values, I would like to give certain examples of L2 of a comma b right away. So, let us look at L2 0 comma 1. Now, in this space we can easily check that the basis states, the basis vectors are 1 root 2 cos 2 pi k